3D printing is a magical technology, and I've been running the Maker's Muse YouTube channel with 3D printing as its heart for many years now, and I've 3D printed hundreds of incredible models. But often when I work on a project and I print it and then I make a video about it, it just kind of gets put aside and forgotten. But I wanted to make a video today to showcase some of my favorite models that I've ever printed on the channel, whether they're models I've designed myself or ones I've gotten from incredible members of the community, and show them in this video in case you've missed them, so maybe I can help inspire you to create something awesome. Let's get started. So let's start at the beginning with this print. This is a file I pulled from a game called Chivalry Medieval Warfare, a game I used to play almost non-stop, and it formed the basis for my first ever, I suppose, breakthrough video on the Maker's Muse YouTube channel. You see, I made a tutorial on how to pull these game assets from the game and 3D print them. And this is the Maul from Chivalry. And that video got picked up by Hackaday, actually, and that sort of helped propel my channel up on a trajectory where it started to grow.
Angus Davison, the creator of the 3D printing video channel Maker's Muse, has posted a video to demonstrate how to extract 3D models from the video game Chivalry Medieval Warfare.
I was really passionate about this process of ripping files and 3D printing like digital assets that I decided to make that tutorial, and that's kind of where it all started. The next 3D print I want to show is one that I haven't really shown on the channel, but I used to use all the time in my in-person 3D printing classes, and that is this, a ball in a little contained grid. And if you know how 3D printing works, it's not that impressive, but just picture this. When you show this to someone who doesn't know how the technology works, they kind of look at it puzzled, and they're like, how did the ball get inside it? And you explain, well, the ball and the grid that's keeping it in place was printed layer by layer at the same time. So this little print proved invaluable during my training classes to demonstrate 3D printing technology and just how powerful it is in terms of printing really unusual geometries. And I've used this concept of having intersecting bodies that can freely move after the print's complete many times since this humble beginning. The next print I just have to talk about is the humble Makercoin. Now, I've printed hundreds of these. I've given out hundreds at trade shows and events I've been to, but the whole basis behind this Makercoin, this little 3D print, was that I was reviewing filament samples, and I needed a small, reliable print that I could print the samples on to benchmark against. And that's where the idea of the Makercoin came from. It's like a 3D printer swatch. And from there, the community just took hold of it, and it sort of formed a life of its own. And creating a Makercoin sort of became like an initiation into your first steps into 3D design and 3D printing. It's an easy file to design. I've done several tutorials on making your own Makercoin, and it's a quick file to print. So it's a great thing to print and hand out to spread this awareness of this incredible technology. And I actually have a few really interesting examples of different technologies of my Makercoin. So first is a PLA Makercoin. This is what most people will be familiar with. PLA, polylactic acid, is a bioplastic made from starch, either cornstarch or sugar beets. You know, really easy to print with, usually a great beginner plastic. And then I have this, which is a resin Makercoin. This is printed on the Poly Moai, and it's a UV curable resin. So it's got this really crazy neon green look to it, semi-transparent, translucent, absolutely crazy. The benefit of resin 3D printers is you can get incredible detail compared to FDM/FFF 3D printers. But the other two on this chain are really interesting. This is SLS, and this is sintered nylon powder. So SLS stands for selective laser sintering, and this is actually solid nylon, well, sintered solid nylon. So it's not completely solid, it's still a little bit porous, but you can get crazy geometries in SLS because the powder that isn't sintered supports the part. You don't need support material. But the most crazy one out of the lot on this entire thing is this Makercoin. So I was lucky enough to visit China back in 2016, and I went to Hangzhou, which is where Shining 3D were, and they invited me, and they had a metal 3D printer. And they're like, hey Angus, do you want us to print something on a metal 3D printer? I'm like, Heck yes, but it has to be really challenging. So I went back to the hotel room with Mesh Mixer, and I mesh mixed this crazy Makercoin variation, and it's got lattices. It's very difficult to print. Anyway, a few weeks later they sent me one. I even made a quick video about it because I was so blown away by this. And this is made with stainless steel powder that's actually melted together layer by layer, similar to the SLS Nylon, but actually metal, real metal. But the thing about this, and I didn't know at the time, is you still need support structures with metal SLM, selected laser melting. And it's not so much that you need support structures because of overcoming gravity, but it's because the parts actually change density as they get melted together, and you also need to dissipate heat. So you need structures to help keep the part in place in the powder bed instead of shifting or deforming due to heat, which is why they've carefully gone through and picked out the support structures, but in some small areas you can kind of still see them. So I do not envy the poor person who had to clean up this print because it's so delicate, but this little group of prints is just, it's one of my favorite demonstrations of 3D printing technology. When people ask me, I'm like, this is what you can do. It's just an umbrella term for many different technologies. But let's go back to this brown Makercoin. Now, unfortunately, YouTube hasn't invented olfactory sense vision yet, but this Makercoin, I can tell you right now, has a incredible strong odor of chocolate. I'm not even kidding. A few years ago, actually 2017, a startup was trying to work on a filament that had smell, and their first prototype filament was chocolate, and they sent it to me. And at the time, people were like, oh yeah, okay, that's interesting, but how long will it last? I can tell you now, years later, this still is overpoweringly chocolate-scented. And it was really interesting as a cellulose-based filament, not PLA. I really wish the company succeeded, but their campaign failed. Really sad to see, because it's an incredibly unique filament. And if I put it on the table, for example, it's sort of a little bit softer than the PLA, right? Really interesting filament. So I'm glad I kept hold of that, because I haven't come across a scented filament since. So that's the Makercoin out of the way. Now let's talk about the Torture Lattice Cube. Again, this is something I designed back in 2016 to test the limits of 3D printing technology. It's incredibly difficult to print on standard filament-based 3D printers. So I designed it back then, and again, it kind of took on a life of its own. So this is one that's printed in resin. This is on the PLA polymer again, and we sort of discovered that resin 3D printers can print lattices really easily. And the reason why they print it easily, but filament-based machines print it, have difficulty with it, is because with resin, you're not so much having to worry about a extrusion path. It's more the cross-sectional area that's challenging. The lower cross-sectional area you have, the easier the parts can separate from that film at the bottom of the resin vat and move up and down. So printing small cross-sectional things like this lattice is really easy, but printing like a block is much more challenging, surprisingly enough. But here's where it gets interesting. So I designed this. Then another company who had a top-down SLA got in touch, and I can't remember the name off the top of my head. I'll put it here. The guy's name was Arthur. Great guy. I hope they're still going. Sent me this. A tiny lattice. But then it got insane. And he also sent me this. This tiny lattice I've kept safe over the years, and it still looks great. I've managed to keep it safe. It's so delicate, but the powers of resin 3D printers to resolve detail is out of this world. But what's really interesting is because lattice prints look impressive, companies started using them as their demo prints. So here I have the Anycubic Photon demo print. Look familiar? They took the concept of the lattice and used it as a demo because it looks impressive, but actually, really, if you know a little bit about resin printing, it's actually easier for them to print lattices than it is for them to print solid, blocky objects. So that's really interesting. The lattice prints, I'm glad I kept some of these on hand, and I've printed so many of these testing other 3D printers. So one of the other things I love to 3D print is mechanisms. You've seen countless mechanisms on the channel, and this is one of my favorites that I didn't design. This is from Thingiverse, and it's Nautilus gears. I'll put a link here to the creator and the original download link. And it's crazy because the gear ratio changes gradually, and then as it comes round, the spiral ends and it goes back to the beginning, and it prints beautifully. This is a fantastic showcase of 3D printing technology to create a complicated geometry. Like, it's not complicated in a 3D sense, but it's very complicated in a 2D sense to design and make this. So using 3D modeling and 3D printing capabilities, anyone can now print these really fascinating gears. I don't know what they'd be useful for, but man, are they beautiful. One of my favorite mechanisms that you can download and print. I also really enjoy looking at weird geometric objects, and this one here is an object of constant width. So the concept behind it is it's basically, as it rolls around, no matter what angle or orientation it's at, the top and bottom contact surfaces are always the same distance. When I discovered these, I was blown away. I was instantly fascinated, and I've done a few videos based on them. They roll, if you have like 3 of them and you put a hard surface over the top of them, they roll as if there's balls underneath. There's like, you know, standard spheres, but they're not spheres. The only thing about these shapes is they don't roll themselves because the center of mass is not actually in the middle of the object. So they do have that sort of interesting property of like self-stopping spheres almost, but they do have a constant height, so constant width. And there's various different types of this object, and I'm still, to this day, fascinated by them. I was also fascinated by this image my dad found me of an ancient lock design where they had these pins that went in and pushed the lock pins out of way, and then you would pull it back. So the actual key looked almost like a toothbrush. And I was so interested, I went ahead and designed one. So this is my version of the ancient Assyrian pin lock. And the key looks like this weird toothbrushy thing. It goes in, aligns with the pins, and then the actual lock bolt can be removed, and you can open whatever you're trying to open. And then again, you put it in place, remove the key, and it locks in place. This was a great model to test. I did a simple version, this is the more complicated version, and I went into the history behind it. And I just absolutely love the dichotomy of combining ancient history with modern manufacturing technologies. And here I have another lock design I stumbled across. This one was a Russian lock design that I've seen used in sheds and things and storage containers that aren't exactly high security, but they're designed, by the looks of what my research was, to survive the harsh winters in Russia and surrounding areas. The key looks really interesting, really strange look, but it goes into the object and then pushes these parts out of the way through a sliding motion, and the spacing between these slots determines the actual keying of the object in to give you a degree of security. Now, it's not going to be a high security lock, as I said. The whole principle behind it, from what I can see, is they're easy to manufacture and they're absolutely bulletproof when it comes to incredibly harsh conditions, when a normal lock, like a normal tumbler lock or whatever, would usually like freeze up or something in similar situations. Puzzles are also a fantastic candidate for 3D printing, and this is a puzzle I designed where the parts actually slide into place with a rotating motion. And there's only 4 of them, but if you undo the puzzle, they have these really weird geometries, and figuring out how they go together is much harder said than done. And I had great fun designing this puzzle because the actual process isn't too difficult. It's using a sweep in Fusion 360, and you give that sweep a twist angle, and it twists that cut through the object to create these really interesting, very alien looking objects, and an actual puzzle that's actually kind of challenging to put together, even once I've done it several times. Another awesome puzzle I came across was this. This is actually a classic woodworking puzzle. So this is known as the impossible dovetail. Looking at it, it does indeed look like it's got 4 dovetails that, like, how did it go together? How did they assemble this? But like with all good puzzles, if you know the right place to line up and tap, then the top part slides open. And when you get it open, you can see inside there's a chamber where you can hide whatever you like, then put it back together, and then give it a good tap. There we go. And it's locked, ready to go. But to create all of these intricate models, you really need to know how well tuned your 3D printer actually is, which is why I designed the Maker's Muse clearance gauge. This is designed to show you what your printer is capable of. It goes from 0.5 all the way down to 0.15 millimeter gaps between walls, which means the 0.15 there's a total of 0.3 plate total, but between each surface it's 0.15. And if your printer is capable of getting down to this 0.15 and it's still movable and it can go to unlocked, then your 3D printer is more than capable of printing any of the models I've designed, certainly, and many others on the internet, and it's well tuned. If you're getting down to 0.3 or maybe only 0.4, you have a little bit of a way to go to making your 3D printer a little bit more accurate to print more complicated models that fit together, which is why this gauge is one of my most downloaded models of all time. So this is just a little collection of some of my most favorite and most influential and important models from the past few years on the Maker's Muse channel. But as many of you who have been subscribed for a long time know, this is not even close to all of them. And unfortunately, not all of them are still with us. So I'd like to take a moment to remember some of my favorite 3D prints that unfortunately I don't have anymore. So thank you so much for watching, everyone. I hope you found this video inspiring. You can 3D design and 3D print. Anyone can do it with a little bit of training and a little bit of perseverance. And all the videos and files that I've mentioned here are linked below this video if you'd like to go check out, for example, the Assyrian old lock or the Russian lock or the puzzle. They've all got videos. I've been doing it for a while, so if you're interested in any of them, you can find them below. Thank you so much for watching. I look forward to seeing you again very shortly here on Maker's Muse. Catch you later. Bye.